the reason I thought I'd bring the slide up was to make it you aware that it is possible to use non-certified components in a passive house. We don't want to be cornered into a situation where there's only a certain number of manufacturers that have actually had their products certified, and we can only use those because then of course that creates a situation where possibly things are more costly than they need to be. The trick is to make sure that the product that you're selecting actually performs as well as a certified component. It just doesn't have the sticker on the tin. And therefore it's a matter of working with that independent company to say, could you give me the validation according to the PHPP criteria? Could you give me the calculations, any evidence that might show that it would comply in terms of, for example, in MVHR, we need a certain efficiency of performance to avoid the need for more consumption of electricity or power to run it, things like that. And in the case of windows, you talked about the fact that the quality of the thermal breaks in the windows are suitable, etc. And any of those aspects, anyone who's considering specifying products, bring them all into the equation in the same way we can consider different variants and what the implications of those are. But in the end, we need to verify and validate the performance of those products to ensure that they would meet the same criteria, even if they haven't been tested and stamped.
Absolutely. And I can speak from experience. When I was researching windows, you can request details and they will be provided. For example, in this case, the windows I was looking at, they did provide information that they're not passive house certified windows, but they have standards that they meet. So,
I mean, just to digress slightly, we talked about the G values of glass earlier. We can't just go and buy a standard set of triple glazed glass hermetically sealed units that go into our frames. We need to ask them for the G values of each of those panes of glass or the overall calculation on that hermetically sealed unit to ensure that the glass that's specified in each layer and the gases in between actually do what we're even to do.
yeah.
Long gone in the days where you just say, I want to replace my single glazing for double glazing, and it just comes off the shop.
Yeah, the details really matter. And yeah, just switching now. So we're inside your retrofit. We call it the badge. So can you just maybe talk us through some of the shading that you might have used or wanted to use, for example, in this house?
So we have internal wooden continental shutters upstairs. Let's go back a step. We had, this cottage was little tiny windows with Georgian panes. If it's possible, perhaps in the window module, that you might appreciate that the more little transoms and mullions, the crosses that you have in the little Georgian type windows, the more points that heat can transfer through, because actually it's not the triple glazing that's the weakest point, it's the frame or the transoms and mullions. So we have shutters upstairs, really probably my choice because I like them. Yes, it would have been better to put something on the outside. We live in a conservation area. You had to consider what would be allowed, and also the impact that would have on the street line. And I designed the PHPP based on putting some brise-soleil on the ground floor, particularly in the kitchen where there's a vast amount of glazing, and that will make would make a massive difference to the summer overheating. And the reason is that as the sun comes in through the window. The primary factors, you've got full floor to ceiling glazing, is that the sun heats up the floor surface, and the floor surface then radiates the heat back into the room. So it's a far quicker process than if you had just standstill heights.
Yeah, absolutely. And just to point out, we're stood in the kitchen now, and you can see the light coming in, which is it's really nice because we haven't got any artificial light here today. This is all just natural light. So yeah, that's a nice feature to think about for us as well. Just wanted to touch on internal heat gains and just flesh that out a little bit and where they come from and
Internal heat gain is really just anything that causes or produces heat within the house. As I say, people, animals, uh, anything that's emitting a background heat, such as a fridge, a dishwasher, a washing machine, a laptop, a driver, anything, perhaps some kit to you like the MVHR or the hot water cylinder. These all have an associated heat output of basically the transmission of heat from themselves into the environment which they're placed in. And equally, pipe runs, so you're running, you're having a lovely big hot bath, you've created lots of heat, and then but the hot water's had to run all the way through the house to get to your bath. That little dispersion of heat loss through the pipe as it goes along, is a heat gain. So there's lots of different factors, they're perfectly natural. It's just evaluating those and understanding the impact that they might have on the performance of the building. And that's more relevant. Obviously, it helps enormously in the winter, and that is more relevant in the summer when I wanted to overheat.
yeah. So on the topic of overheating, have you noticed yourself living in a house that's NFIT certified? For example, if you have a large gathering or something like that, there's a lot of internal heat gains. You know, can you speak to some experience of that,
I
or
had two really large gatherings recently.
especially with COVID?
That's I am very aware that if a shading strategy is good, that you can maintain the internal air temperature that the MVHR provides, which is 20 degrees, and be open a door and go, woof, that's hot outside, that's 26, 30 degrees, whatever it's been this summer, and really notice the difference. The house will perform to keep that constant temperature. And a lot of people are like, wow, 20 degrees, that seems really hot. I wouldn't want to live in a house that's 20 degrees. Um, People might have their heating set in the winter, or maybe this winter much lower, but on the whole between 17 and 21, depending on the room and how static people are. Um, the thing is that because the way we've always lived, we think that a hot room means a stuffy room, and therefore we're impelled to open the windows to get the fresh air. If you're in a passive house that's at 20 degrees and there's no drafts, and I can't stress this enough, you don't feel a change of temperature that would cause you to say, I'm feeling a bit chilly on the right hand side, or I need to put my slippers on, then provided you have the MVHR giving you a constant flow of fresh air, you don't go too hot.
Yeah. So in actual fact, and we do talk about this, we share a great video on it as well. It's not just the heat; it's the ventilation, it's the humidity as well. All these factors that come into it. So you shared a balance, which I quite liked. A real good image. I don't know whether you want to go to it, and just just talk about. I mean, we are talking about this now, but just kind of talk about it in practice for you and how you might, um, live in your house and think about these things. The idea of actually having an education about how to look after your house. It's important.
Yeah. I think perhaps now is in 2022 is a really good time as people are naturally more aware of it. If we leave appliances on, such as laptop chargers with their transformers, or we leave things on, it's going to cost us in terms of electricity. Our instinct is to be more cautious and not leave things on. And equally, we're using or reverting to LED lights as opposed to bulbs that would get hot. These things like that we could consider. Yes, they cost more to buy in the first place, but they last longer and they don't use so much energy, and then they also don't emit as much heat, radiate as much heat, and all these little things, that would make a difference. In the design stages, we talk about how much glazing is acceptable on a north elevation as opposed to south elevation. Obviously, we don't get the sun in the north, so we don't want to be putting the glazing in to try and heat the house up. We perhaps might need it for security or connection between spaces, or we might need it just to give some light. That's fine, but we wouldn't choose to put too much in the north side. And on the south, we equally wouldn't overdo it. We wouldn't overcook it. So these are all things, as I say, that essentially the glazing on each aspect, how we might have strategies for ventilating. If we forget to shut the blinds, can we open the windows? Is it safe to open the windows? If I come home from a day out, can I, quickly open the windows for 2 hours? That fixes the problem. Do I want to sleep with my window open at night? In a passive house, that you don't have to have all the windows shut. You can have them open. You can have your inside-outside living. It's just that when you do shut it down, it will keep the ambient environment constant. So we talked about U and G values. We talked about the shading strategy. In the end, when you live in one, you should be given some indication of those factors and how you might operate the building. And equally, you want to change your MVHR filters at the manufacturer's specified times so that they become dysfunctional and don't give you enough fresh air, all those sorts of things. So there's a few perhaps different concepts on how you would operate in the house, but on the whole, they're very easy.
Ye Yeah, it's not something to be scared of, but, in different cultures, for example, Spain, I understand that there's quite a habit there where they do close all the windows up.
Totally.
Yeah, so it's just part of their culture.
It is, yes. So, that you go around a Spanish or an Italian street on an afternoon, you won't find many people still without their shutters shut, and that's because they want it to be cool. Yeah, so it's just a different approach, and unfortunately, at the moment, we're not bringing that into a lot of the house design, and we will, Pure House will, but a lot of people aren't.
Yeah, so we do talk about this in quite a bit of detail, when we're breaking down traditional, build types and such like. You touched on the fact that you had 8 different wall types. Could you just give us a couple of examples of the different wall types off the top of your head and what you
Yes.
did with those, for example?
We had 4 or 5 party walls, which are obviously linked to other people's living rooms or spaces. So, there's only a certain amount that you can do within those party walls. We had,
And what are those patio walls made of?
well, mostly open, unventilated cavities with no insulation.
Okay.
Um, Sometimes quite damp. Um, we also had walls that had 3 or 4 layers of masonry, um, with gaps in between, and actually it was impossible to tell which was ours and which was theirs, so we had to sort of work with that. We had, solid masonry, brick, double brick or cobble walls. Yeah, a combination of all sorts, and sometimes from one floor to the next it would change. So, for example, where we've gone above the party walls, where we've been allowed to, we've then reverted back to a passive house form of construction that would give us a better U value, than was attained on the floor below. So not all the walls perform to the same level in this house because we can't have the fabric failing, in terms of the condensation, mold growth. We have limits on what we can apply depending on the build up of you.
So you had to model all that before you started implementing it. And am I right in thinking that you largely used wood fibre with lime?
Yeah, so I'm a great advocate of stopping the blocking of vapor movement, water vapor movement in solid wall construction. We call it water vapor permeability. It's very easy to block it and hide it and manifest damp. And we had the approach that we would actually embrace it and saying we're going to allow these walls to breathe. So we used vapor permeable materials that included lime parge coat with a slurry that actually is your airtight layer. It included wood fiber insulation in boards that you applied that leveled slurry. It include lime plaster and then paints that are specific, internal paints that are specifically water vapor permeable. And again, we're getting into great detail here, but a bit like thermal conductivity, whether you go to Farnball or you go to Dulux or you go to Leyland or you go to Beek or you go to whoever, they all have different allowances of water, allowances for the amount of moisture movement through those paints.
Yeah, so right down to the paint. You haven't seen
Vertebrates is, what houses that we're going to perform if I put a paint that's perhaps a Bastrum paint on that you think is going to resist the condensation on the walls. But then is it also going to trap moisture into the fabric? Now, bearing in mind that actually, if you've got a pass, you shouldn't really have any condensation on the walls anyway. So
Yeah, and you mentioned the lime slurry, and I know from experience, the lime strategy it's different, slightly different to plaster, and so there's a real knack to it. And so we really want to encourage people to understand the nuances there. Maybe at some point in Pax Build session, we'll
yeah, it's a great product to work with. It's just a great material. It's really good. Also, it's health and safety to consider whether you're using cement or lime. But it's a traditional trade. It was used, consistently until the gypsum world took over, and I'm a great advocate of it. Yeah.
Oh, brilliant. So just one kind of thing to point on. You talked about the 10 to 2% overheating model. That they've just
Oh yeah.
revised. That's it. The stress testing for the overheating modeling. Do you wanna maybe just talk around that a little bit further and just underline the importance of making sure that you don't overheat when you're doing a retrofit, because that is a real risk. You can overheat.
Absolutely. I think the simplest way of explaining that is that if the environment outside is more humid and hotter than the environment inside, we have the opportunity here to control the environment inside without using air conditioning, which is a resource on the energy, in terms of energy. It's not carbon friendly. It requires refrigerants and all sorts of things that we need to avoid. And it's actually not the most nice, that's not terrible grammar, not the nicest environment to be in anyway, in an air-conditioned environment. It can get a bit chilly. And therefore, we have the capacity to actually control that and avoid high stress testing, overheating being an issue through the design.
Yeah, so we're modeling this overheating risk and we're managing it, and also we're drawing on data for climate change as well. That's really important because you see the change.
Yeah, we always include 2030 climate change strategies, and the stress testing takes it way beyond that. So it assumes, 1.5, 2 degree temperature changes, which are relatively catastrophic for us anyway. Will this construction cope with that? And that's future-proofing the life of the building, which is really important.
Yeah, and I think that's where the term "homes for the future" comes from. So yeah, thank you for that, Claire.
That's okay. Thank you.